Hi everyone, welcome to editorial video of Codeforces round 818 problem D. And in this problem, we are given 2 to the power n participants which participate in a knockout tournament. And each participant plays with its next player, and one of them proceeds to the next level, and other gets eliminated basically out of the tournament, right? So after all the matches, there will be only one player left, and which is declared as winner of the tournament. Now what we have is, we have some sponsors, and what they can do is, they can change results of at most k matches, like um, by changing results. What I mean is, um, if the left one is winning, after changing a result, the right one will win. And if the right one is winning, after changing the results, the left one will win. Right. So what we need to find is, um, we need to find minimum number. We need to find the distinct number of participants that can win regardless of sponsors making at most k changes. And as you can see that n is 10 to the power 5. So the answer can be like pretty big. So we need to output it modulo 10 to the power 9 plus 7. So we will be using modular arithmetic, which is prerequisite for this video. Let's visualize the problem. So, okay. So we are given that we have 2 to power n participants. So let's take an example of n equal to 3, right? So there will be 8 participants. One, 2, 3, 4, 5, 6, 7, 8, right? So these two will participate, these two will participate, these two will participate, and these two will participate. Some of them is going to win, and other of them, other one is going to be eliminated from the tournament. So one of them wins, one of them wins, one of them wins, one of them wins. Again they participate. So one of them wins, one of them wins, and again they participate, and one of them wins, right? Right. So as you can see that there are 2 to power 3 participants. Now the participant gets half, because in one match one gets through and other gets eliminated. So the total number will be half. So it will be 2 to power 2, it will be 2 to power 1, and it will be 2 to power 0, which is 1. So this will be winner of the tournament, basically. Okay. So let's see some important observations. So who can be this guy? This is the winner. Who can be this guy? If we choose a path, this is a binary tree basically. So this is the root, and all these things are leaves, right? If we choose a path from root to leaf, right? Suppose if we choose this path, and this path, then this will be the winner, right? If we choose this path, and this path, then this will be the winner, right? If we choose this path, and this path, then this will be the winner. And similarly, if we choose any path from root to any of the leaves, then the path, uh, the leaf to which our path is pointing to, will be the winner. So basically, my winner is dependent on the path from root to leaf. Winner dependent on path from root to leaf. So let's understand what our sponsor is doing. So for that, let's take this route, this path, and this path, for example, right? So we will get this thing as winner, right? So suppose what a sponsor can do, a sponsor can change any of the path, right? So let's say sponsor changes this path. So earlier we were taking right. Now we will have to take left, because sponsor has changed the path, right? So this will be the winner. So winner will be different, right? Uh, for example, let's take another example. If we were choosing this path, what sponsor can do? Sponsor can change the result of this match. So instead of taking right, we will have to take left. Now over here, like there must be something we were taking initially. So let's suppose it was left, sorry. So then the winner will be this, right? So okay, now which means that sponsor can flip at most uh, k paths, k characters of the path, right? So if I am having level S, I am having NS3. So my path will consist of three characters. So let's suppose take an example, right? So suppose initially is LRL. Okay. Now K is zero. Suppose sponsor can't do anything. So we don't have to change anything. So there will be one way, one path, which means only one distinct winner. Now suppose K is one. Now, what sponsor can choose is sponsor can either choose to flip this thing or this thing or this thing. If we choose to flip the first L to R, then it will be RRL. If he choose to flip the second character, it will be LLL. And if we choose to flip the last character, the path will be LRR, and all three will be distinct paths, so it will lead to distinct winners. So we have three distinct paths when k is one. So if we use the formula for how this three is coming, it will be basically 3C1. It will, and for over here it will be 3C naught, uh, because we are choosing zero place in out of three places. We are choosing one place out of three places. So what will, if we summarize this thing, what will uh, what will be my total answer? My answer will be NCI, summation of NCI, where I is equal to 0 to I is equal to minimum of n comma k. Okay, so that was my final answer. So let's look at the code now. So this is the code. Let's see. So this is the function where I am solving the problem. So first I'll take input of n and k and initialize my answer as 0. Then I'll run a loop from 0 to minimum of n comma k, and I'll add ncr to my answer where n is n and r is I. I is from 0 to minimum of n comma k. And what is ncr? This function is ncr, like basically which is calculating n factorial upon r factorial into n minus r factorial, and it is taking care of modulo arithmetic. Like I have pre-computed mod ins using this pre-computation, and also factorial of uh, I using this computation, and I am returning factorial n into mod n of r, which is n factorial upon r factorial, which is divided by n minus r factorial, which is the formula of NCR. And I'm returning the answer, and it will calculate and it will output the answer. So that was the code of the problem. If you have learned something new from this video, hit the like button and subscribe for further editorials. Thank you and have a nice day.